Hello Professor, this is our update 3 and in this stage we started moving beyond EDA and into building our modeling pipeline. Let me start by showing the setup for our regression models. First we filtered our dataset to only include players who played more than 500 minutes and had a valid market value. This gave us a high quality modeling dataset. Next we defined our core feature set: age, minutes, goals per 90, assist per 90, xg per 90, xag per 90 and the positional strength index that we built in update 2. We then built models separately for each positional group: goalkeeper, defense, midfielder and forward, because a combined model doesn't make sense in football. For each position, we trained two models: linear regression and random forest regression. Here are our model results. We can see that linear regression consistently performs better than random forest, especially for midfielders and forwards. That's why we selected linear regression as our base model for the value prediction. This comparison helped us understand which position the model struggles with and allowed us to make an informed choice before predicting market values. Now, Raja will explain how we gathered predicted values for players and how we use those predictions to build team-specific recruitment recommendations.
Building on model results, my part focuses on converting these predictions into actionable insights. The first thing we did was generate predictor player values for all four positions. We trained the best model for each position and assigned a predicted value back to every player. After that, we calculated a value gap, which is simply the predicted value minus the actual value. A positive value gap means a player is undervalued, a potential bargain. So these are our undervalued players tables and overvalued players tables. Here we have the top 10 undervalued players for each position group. These list looks reasonable because they mostly highlight the hidden value players like Bogley, Gross, Hammer, Chong, Mbai, Olse and so on. Players who often outperform the market value. Next, we need a PSI metric to identify weakness inside each Big Six team. For example, we found Arsenal's weakest area is the forward. Chelsea struggles with forwards and midfielders. Liverpool lacks midfield depth. Manchester United has three weak zones: defender, midfielder, and forward. Tottenham needs a midfield improvement. Man City has no major weakness, but they're all average. Finally, we combine both the systems, team weakness plus undervalued players, to generate recommendations. So for Arsenal, we got the recommendation of forwards Mbayu, Olse, Otengo. For Chelsea, it was Chong, Lemma, and Hammer. For Liverpool, it was Gross, Lerma, Hammer, etc., and so on for the all six big teams. Each list is position aligned, price filtered, and age filtered, and then finally cleaned for realism. Before we go into the final presentation next week, this graph draft just shows the overall shape of our recruitment engine. As we talked in class, we have not yet completed all 9 model variations or tested our ensemble models, which will be our last part for the final. We will next refine our PSI model, remove repetitive recommendations, and tune our machine learning models and deliver a polished end-to-end systems with the best possible recruitment results.